Alright, here we go again. Mass to mass conversions. More stoichiometry. I know it's our favorite thing to do. Alright, so some things that you're going to want is have your mole map with you, your flow charts, okay, of the moles. Today we're doing mass to mass, which means we're going to be going from grams of one substance to grams of a totally different substance. And so we're going to do that. Alright, so mass of one substance to mass of a totally different substance. So let's look how many steps it's going to take. We're going to have to go from mass to moles. One step, using our molar mass. 2 step to convert moles of our starting to moles of our ending substance. And then, a 3 step. Yep. There's only one thing better than a 2-step stoichiometry chart, and that's the 3-step Phlegm charts. Alright. We're going to need this periodic table in a few minutes. Here we go. So we are given 3.21 grams of bromine reacts with excess lead. Remember, when this says excess, this means you have a whole bunch. We don't have to worry about it. How many grams of lead bromide would be produced? Alright, bromine. I'm just looking for the elements. Remember, that's one of those fun diatomic ones here. So I got 3.21 grams. That's what they gave me. I want to know how many grams of lead bromide we're going to find. That's lead and bromine together, so lead bromide's right here. So I want to know how many grams. So in our charts, we always start with our given 3.21 grams of bromine. Alright. I don't want grams of bromine, so I know grams of bromine is going to go down here. And we can go from grams to only one thing, and that's the mole. Right? And let us remember that when you have grams and moles together, the chemical has to be the same. So Br2 and Br2. But we don't want moles of Br2. We want to go to moles of Pb, Br4. Alright, if we flip back to our mole map real quick, we'll see we went from grams to moles, and now we're going from moles to moles. Alright, remember, when a mole and mole is over each other, this is where you can change your chemicals at. Notice these are 2 different chemicals, bromine, lead bromide. Alright, mole and mole together, where do we get our numbers? From the coefficients of the balanced equation, and we already have a balanced equation here. So, for Pb, Br4, no number there means 1. For bromine, that's 2. Alright. Lastly, we want to cancel out moles of Pb, Br4. And now I can go to grams of Pb, Br4. Alright, let's get our numbers. Sorry, I kind of jumped ahead and did the numbers there already. Mole and gram together, hopefully remember the mole is 1. Grams from our periodic table. We jump back and find bromine, which is right here at 79.9. So bromine is 79.9. There are 2 bromines here, so make sure you multiply by 2. So 79.9 times 2 gives me 159.8. Alright, let's go over here. Since we already did these, I'll just remind you, mole and mole, once again, numbers from the coefficients. So there they are. Alright, mole and gram together, my mole is 1. Grams from the periodic table. Alright, let's go back and find lead, Pb. So, lead is way down here at 207.2. So lead is 207.2. There's only 1 lead in here, so that stays. We found bromine a couple minutes ago. It's right here at 79.9. This time there are 4. So 79.9 times 4, we get 319.6. And we're going to add these 2 up. So add our 207.2 to our 319.6, and you are going to get 526.8 grams of PbBr4. Alright, watch what happens. Grams Br2 goes away. Moles of Br2 goes away. Moles of Pb, Br4 goes away. What are we left with? Grams of lead bromide. How many grams of lead bromide? That's what it asked for. So, multiply on top, divide on bottom. So we got 3.21 times 1 divided by 159.8 times 1 divided by 2, then times 526.8 divided by 1, and you get the grand total of 5.29 grams of lead bromide. Alright, that's it for this one. Let's try one more. Alright, not going to do too many in this one. They all work the same way. So here we go. We got grams of aluminum reacts with excess chlorine to produce how many grams of aluminum chloride? So I got 14.2 grams of aluminum. How many grams of aluminum chloride? That's this one. And I want grams. Remember that excess chlorine means you have a bunch, not a part of the problem. Okay? So 14.2 grams of aluminum is our start of our phlegm chart. So that's a nice straight line I just made. Alright, I want to cancel out grams of aluminum and go to moles of aluminum, right? Remember, grams down here, it's got to be mole. When you got grams and mole together, got to be the same chemical. Alright, but I don't want moles of aluminum. But I can go from moles of aluminum to moles of what we're looking for, aluminum chloride. Remember, mole and mole, that's when we can change the chemical. And lastly, I want to get rid of moles of aluminum chloride, alright, and go to grams of aluminum chloride. Alright, let's get our numbers. Mole and gram together. My mole is 1. Aluminum from the periodic table. Our aluminum back here is 27.0. So 27.0. Okay, and there's only one of it there, so we can just write it in. Mole and mole together. Numbers from the coefficients. Just match them up. AlCl3 is right here. It's got to be a 2. Aluminum's right here. It's also a 2. Lastly, mole and gram together. Once again, notice, same chemical. Grams and moles together, same chemical. My mole is 1. Mass from the periodic table. We just saw that aluminum is 27.0. And there's one of those. Chlorine, maybe you have this memorized, maybe you don't yet, but it's 35.5. And there's 3 chlorines, so we're going to multiply this by 3. So 35.5 times 3. Add it to our 27. And our molar mass of this is 133.5. 133.5. Alright. Notice grams cancels out. Moles of aluminum cancels out. Moles of aluminum chloride cancels out. We're left with grams of aluminum chloride. That's what it asked for. That's a good thing. Multiplying top to bottom, 14.2 times 1 divided by 27 times 2 divided by 2 times 133.5 times 1, divided by 1, and you get 70.2 grams of aluminum chloride. Boom. And that's how you do mass-to-mass problems. Alright? So, try the ones that I've given you in your packet. Make sure you're writing these samples down. And if you have questions, I'll get them in class.